Hi, welcome back. This is 7.4. So we did a little bit of an introduction in class already to theorem 7.5, the triangle proportionality theorem. And I am moving right into our first example. So we are told that PT is 7.5, TQ is 3, and SR is 2.5, and they would like us to find PS. So before I can do anything, I need to really label these parts because otherwise I'm going to get lost. And PS is going to be X. Okay, so we are saying that the ratio of PS to SR is going to be equal to the ratio of PT over TQ. So I'll just write that. All right. Important to note, my two longest sides, my two longest sections are kind of grouped together. I don't have them like diagonal to each other. So cross multiply. And X would be 6.25. So that means that PS would be 6.25. And that's all. Okay. So I will let you do a try problem, or I'll give you one. We are going to use this shape again, but I'm going to give you different side lengths. Okay, so instead of these, I'm going to say if PS equals 12.5, SR equals 5, and PT equals 15, find TQ. All right, so give that one a try. And when you're done, you should have 6 as your answer. So if you don't, try to figure out what you did wrong, and I'll be happy to help if you can't figure out what happened. Okay, so the next thing that we need to look at is simply the converse of the triangle proportionality theorem. So theorem 7.6 is the converse triangle proportionality theorem. So instead of saying, okay, if two lines are parallel, then we have these proportional segments, we're going to be saying if we have these proportional segments, then the lines are parallel. So if this is the summary, if proportional segments, then parallel sides. And that's referencing 7.5. So that's just the opposite of 7.5. Here's example 2. So that's just going to be working backwards. We have the same shape, but we don't know the lines are parallel because we're proving that. Okay. So we have our two triangles. EH is 3, HF is 9, DG is a third of the length of GF. Ooh, mixing it up here. Are GH and DE parallel? So for this, we need to write DG in terms of GF. So this is something that I think we've touched on a little bit here and there, but it's a pretty cool trick. So if you have something that's a third of the length of something else, what you're going to do is take GF and you're going to call it X. And then we're going to call DG 1/3 of the length of GF. So it'll be 1/3 times X. And since that's DG and GF, we are going to write this as, oh, well, this explains like what's happening here. They actually do kind of the opposite, and they say GF is 3 times the length of DG. Doesn't matter. Anyway, what's happening here is if we have something that's a third of the length of another thing, that means the scale factor is 1/3. So we're just going to put 1/3 as the ratio for the scale factor, and then we know that it has to be proportional to EH and HF. And if this works, then it is parallel. So then we have 3/9, and yep, that's going to be the same thing as 1/3. So yes, they are parallel. Yay! All right. I meant to end the video at the end of example 1. So we're going to skip a try problem for this one. I'll see you in the next video.